Hey dosers, welcome back to another video. Today we're going to be tackling sequences. So in sequences we're going to be talking about the sequences basics, arithmetic sequences, geometric sequences, financial math, Pascal's triangle, and the binomial expansion. So let's get right into today's video. So today we're going to be starting off first with sequences basics, the basics. So the definition is once again given on the screen, but this is just the overall message of a sequence. So I'm going to explain what an arithmetic and a geometric sequence is. So let's get started. Yes? Wait, this is the wrong pen. Sorry. Yeah. Okay, so a, an arithmetic, just say A for simplicity. An arithmetic goes up in one consistent common difference. A common difference is what is different between an arithmetic and a geometric sequence. So if let's say over here 7, 5, 3, 1, -1, etc. So this is an example of an arithmetic sequence, and this consistently goes down by -2 and -2 again. Sorry, this is 3 over here, and then another -2, and then another -2. So this is going down by a common difference. Yes? Now let's talk about geometric sequences. So an example of a geometric sequence can be anything. So a geometric sequence can be something like 2, 4, 8, 16, 32, etc. So this is all being multiplied by 2, and etc. So over here, you are multiplying each term by 2, so it's a common ratio. Common ratio. That's the difference between a geometric and an arithmetic sequence. I hope that makes sense. Now, there are two types of sequences in general. So there's a finite and an infinite sequence. So a finite sequence is when there's no dot dot dot. There's no ellipsis, this, at the end. So if this is indicated over here, this is an infinite sequence because it goes on until infinity, or negative infinity in this case. But over here, it ends, the last term being -3, and this is a finite sequence. And this is really important for solving questions based on it. So let's get into it. But before we talk about arithmetic sequences specifically, we're going to talk about something called the sigma notation. So the sigma notation is a way to express the summation. So this is the sigma notation. This is sigma notation. Yes? Not this. Uh-oh. Not this dude. This is sigma notation. Right? So this sigma notation over here, what this indicates is the summation. So as you can see over here in this diagram, the largest value that r can take, r being the variable that we're doing. So this can be any sort of equation, general term, anything. This is the largest term, 10 being the largest term that r can take. And the smallest value r can take is represented by r is equal to 1. So this can be anything. So r can be represented by I, j, anything. But the smallest term goes at the bottom, the largest term goes at the top. So this means that when you're doing this, it means the summation of the equation that you have, in this case r, from 1 to 10. So it goes 1. And then the next term being, it goes up by 1. It goes up to another one. So 2, plus 3, plus 4, plus 5, plus 6, all the way to plus 10. And then the final value, which you get, that's represented by the question mark, is your answer to your sigma notation. And I hope that makes sense. It's basically summation, and we'll get into more of that later. So arithmetic sequences. Now the definition is once again listed over here. I just want you to focus mainly, the main part over here is this part, the formula. So the formula is the main thing that you need to know. You don't really need to know much of the definitions for Maths AHL. You just need to remember that arithmetic has common difference, CD, yes, is A, arithmetic. G is represented by common ratio. Yes, that's what you need to remember. A and G, A, CD, G is CR. Yes? So this is the formula to find, let's say you have an arithmetic sequence, once again, goes 1, 3, 7, 9, 11. Yes, this is your common difference. And once again, I'm listing over here that this is a finite This is a finite arithmetic sequence that we have over here. Yes, and if they ask you to find the last term, for example, you just count how many terms there are. So 1, 2, 3, 4, 5, and you plug it into the equation. This equation over here, this is to find any term in the arithmetic sequence that you have. This is the equation you need to remember, right? I just want you to take a moment to read this if you want, and you'll be able to understand this equation soon enough. And this equation works because of this. This explanation is pretty self-explanatory, but I'll still go through it in a little bit. I just want you to take a moment to go over this. So we've already made it clear that a common difference is in arithmetic sequences, yes? Common ratio is in geometric. So u1 is your first term. That's what's given in the formula. So u1 is equal to u1, the first term that you have, right? We can't really do much with that. But u2 is u1 plus d. D being your common difference. This is your common difference, CD. So this over here is represented by common difference. Your U3 is the same. It can be U2 plus D, or it can be U1 plus 2D. D just keeps on being added. That sounds a little bit weird to say, but the D just keeps on being added again and again and again for each term that you increase. So that's what this equation over here, that's what that represents, right? So to find un, n can be any number in an arithmetic sequence. So let's say you have an infinite sequence. Let's say this was infinite instead, and they could ask you to find the 1766 and 1700. I can't even speak. 1070th. Let's just say 70th for my comfort. 1070th term. So you plug in, instead of n over here, you plug in 1070. And you plug in u1 and you common difference. That's how you'd use this equation. So this is an example question, and I want you to just take a minute to solve this if you can. Yeah, so I hope you've attempted it by now. If not, just still pause the video and we'll go through it. So the first term of an arithmetic sequence is -7. So u1 over here is -7. The fourth term, so u4, is 23. 23. So the sum of the series, sorry, this is the wrong slide. Oh my god, I'm actually, something's wrong with me today. It's too early in the morning. Anyway, the fourth term, let's do this question. So I'm gonna read it out. The fourth term of an arithmetic sequence is 18, and the common difference is -5. Find the first term and the nth term. So we have the fourth term of an arithmetic sequence. So we have u4 over here is equal to 18, and the common difference, so d, is equal to -5. So you're supposed to find the first term, so u1, and the nth term. And I'll get into that after we find the first term. So we know u4 over here is equal to u4 is equal to 18, right? So if you plug it 4 into this equation that we have over here, so u4 is equal to u1, so you're trying to find u1, plus n minus 1, so 4 minus 1 times by d, -5. So over here, you should get this is equal to 18. So u1 plus, because u4 is equal to 18 as we've gone through. So u4 is equal to u1 plus 3 times -15. So u1 can be given as, so what's 3 times 15? 45. 45 minus 18 is 27. So -27 is what u1 is. u1. Yes? I hope that makes sense. Wait, there's something wrong here. Am I tweaking? I think I'm tweaking. Somewhere over here I'm tweaking. Oh, wait, sorry. This is supposed to be... Oh my gosh. Sorry. My mistake, sorry. So 3 times -15 is -45, obviously. So it has to be positive. It has to be a positive value for u1. So positive 63. That's what it would be. Yeah. 18 plus 45, yeah. u1 is 63. So now that we have this, we're trying to find the nth term. So to find u of n, I'm going to tell you right now, you're not going to get a singular value. But you need to plug in each of the things. So you go back to your equation over here, you know what u1 is, right? You know u1 is not a negative number. Sorry about that. Again, it's 63, positive 63, plus n, because they haven't specified. Nth term is not specified. So n minus 1 times by d, which is minus 5. And you expand this and you write it in terms of n. That is your nth term value. And I hope that makes sense. And if I did something wrong again, please do let me know in the comment section and I will correct myself. So let's go through the sum of arithmetic sequence. So this is the equation for the sum of the arithmetic sequence. There's 1 and then there's 2. So I'm going to go through both of them for your own convenience. So the most common formula that we use is S of n. So sum of n terms in an arithmetic sequence is n over 2 times by 2 times the first term plus n minus 1, right? N minus 1 times by d. And this entire thing multiplied by n over 2. This is the most common formula. And I'll tell you why in a bit. And then the less common but still usually used in some formulas, some really like challenging formulas, is this one. So this formula is n over 2 times the first term plus u of n. So this can only be used in finite sequences. And I want you to keep this in mind. You cannot use this formula everywhere. This formula, you cannot be using this anywhere. Everywhere, sorry. This can only be used in finite sequences. And there's a reason for that too. The reason for this being only used in finite sequences is because u of n over here, this is u1 and u of n, this is your last term. Last term. This has to be your last term. So let's say you have another arithmetic sequence, it goes up in 2's once again, and it's infinite. It's represented by ellipses. How are you going to use this formula to figure out what your last term is? If it gave a specified value for S of n, right, then it would be fine. But in this case, they haven't. Usually, when it's represented in this question, they ask for the sum of the total arithmetic sequences. But they will never ask you that when it's giving you an infinite sequence. In an infinite sequence, you will not know what the last term is because the number of terms that are in an infinite arithmetic sequence go up to infinity. So you will never know the value. So only in finite sequences will you be asked to use this. And I want you to keep this in mind. This formula, on the other hand, is the most common and preferred method. But if you cannot use this for any reason whatsoever, because let's say the question is such that you cannot find what your common difference is, then you would be forced to use this. Yes? Now let's go into this question that we were doing earlier. Sorry about that, once again. So let's go through this question, yes? So you know u of 1 is equal to negative 7, u of 4 is equal to 23. Yes, because it's said in the question over here. And the first term of an arithmetic sequence is negative 7. So the sum of the series is 689. So now the sum of the series, this means this sequence is finite. This sequence is a finite sequence. But again, this doesn't mean that you can find out, that you can use this equation over here. And I'll go through that now. So let's say this sequence is represented by negative 7, u2, u3, and u4. u4 is 23. Yes, and then it goes up to infinity, right? And S of n of this is 689. So for the equation that we were looking at before, it's S of n is equal to n over 2 u1 plus un. So you have only u1 over here. You don't know what n is, as it says the sum of the entire sequence. This means the entire sequence is 689. This is 689. You don't know how many terms are in that arithmetic sequence. And not only that, you don't even know what the value is of the last term in that sequence. And you don't even know what number, how many numbers are there in that singular sequence. So you cannot use this formula. We are forced in this case to use the other equation, which is, let me write it out. Always write down your equations. And it would be ideal if you could memorize these equations. So 2 times u1 plus n minus 1 times d. It saves time in the exam, so that's a top tip right there. Memorize these equations. They are given in the formula booklet, but still memorize them. It saves a lot of time. It might not seem like much, but it saves a lot of time when it adds up. So let's use this equation over here to solve our thing. But if you try with this equation right now, you will not be able to solve it. The reason for that, as this question is a little bit more complicated than it seems. This question is going to force you first off to use the equation we learned in the first page, like the first thing that we did in arithmetic sequences. We have to use this equation over here. So that equation is un is equal to u1 plus n minus 1 times d. Because if you try to use this equation again, you're faced with the same problem. You're faced with the same problem, the same issue over here, which is you don't know what n is. You don't know the number of terms, and you don't know u of n. So that's what you're faced with. That's the issue you're faced with over here. And you don't even know the common difference either. So that's what we're going to try to find using the first equation, this equation right here. So let's solve this equation. So u of 4 is equal to 23. Yes? So 23 is equal to u1 plus 3d. That's correct, right? And now we know where u1 is. 23 is equal to minus 7 plus 3d. So from this we can get d is equal to 10. Yeah? So now we finally found our common difference. So we use this and plug it into this equation over here. So once we plug it into this equation over here, we expand and everything. We multiply this n inside once this is a little bit more simplified. We replace u1 with negative 7, and you should end up with this equation over here. So 10n squared minus 24n minus 1378. That's the equation. I'll write that a little bit smaller so that you can see that. Okay. 10n squared minus 24n minus 1378. Now, just separate that off. Yeah, that's what you should be getting. So 10n squared minus 24n minus 1378. That's after you plug in d is equal to 10 and u1 is equal to negative 7. So now, using the quadratic formula or factorization, whatever you guys prefer, you can even put it into your calculator, you should get n is equal to 13. And you should get another value for n, but since that value is negative, that value is ignored. And the reason for that is because n is represented by number of terms, and you can't have a negative number of terms. So n is equal to 13 is your final answer. I hope that makes sense. Now let's move on. So we're going to be talking about geometric sequences. So remember what I said. I want you to read this if you want. That's your own choice. Pause the video and read this. But I will be focusing purely on the formula, as that is what you mainly need to know. So the formula for a geometric sequence is a little different. So un is equal to u1 times r to the power of n minus 1. That's what it says here, yes? But there are some rules over here. So in a geometric sequence, r can never equal to 0. Now r is represented by, the common ratio which we have in every single geometric sequence is represented by r. That is what the common ratio is represented by, r. So if r is 0, you will just have a repeated unit. So if u1, let's say, why isn't the cursor working today? Sorry. u1 is equal to 7. So if r is equal to 0, you're just going to get 7, 7, 7. This isn't a geometric sequence. Sure, you're multiplying it by a common ratio, but you're just getting the same value again and again. And that isn't a geometric sequence. So that cannot work. And u1 cannot be 0. Because if u1 is 0, you're just going to get 0, 0, 0, 0, 0. Yeah. That's what you're going to get if r is equal to 0. Yeah, if r is equal to 0 also, you'll be getting this. I made a mistake over there. I'm tripping today hard. Yeah, it will be 0, 0, 0 if r is equal to 0, or both of them are equal to 0. Then you will just get a repeated unit of sequence. So u1 cannot be 0. Now, I hope that makes sense. Now, I'm going to go through this again, this part over here, which explains the equation. So u1 is once again equal to u1. That's the same. u1 is equal to u1 times by r. u2, sorry, this should be u2. u3 should be equal to u1 times by r squared. Now you see a pattern over here, obviously. You're just multiplying it repeatedly. You're multiplying the common difference repeatedly again and again and again and again, which is where you get this formula from. Now, I think it'll make a little bit more sense once we do some applications. So this is an example of geometric sequence. So find the common ratio and write the next two terms of the sequence. So I want you to just focus on the common ratio, as multiplying is pretty easy. So don't focus on this. Just try to find the common ratio for now. Just find the common ratio. Yes? I'm gonna give you a minute for that. It shouldn't take too long. It should take like a minute to do all three of these. So I hope you solved it now. I realize that I have not given you a way to find the common ratio, but this is what the challenge was for now, and I hope you guys were able to figure it out. If not, that's fine. I haven't given you how to find it. So R is what you're trying to find. You're trying to find your common ratio. This is your common ratio. So you know that this times this is the same as this times this. Yes? And that's never going to change for any number in the geometric sequence. The term before it times by the common ratio is going to give you what the next term, right? So if you do this term divided by this term, so let's do 5 over 2.5. That gives you 2. That is your common ratio. Don't believe me? Okay, 10. Let's take 10 then. So if we take 10 over 5, that also gives us 2. Because you're multiplying 2 every unit you go up. Every number you go up, you multiply by the common ratio, which in this case is 2. Now it's the same over here. Just because it's descending over here, just because the numbers are getting smaller over here, doesn't mean it's any different. R is equal to 3 over 9, which is 1 over 3 once you simplify. 1, right? Let's take 1 in this case. So R is equal to 1 over 3. 1 and 3. It's the same thing. Now this is represented by variables. X, it's given by x. Same thing applies here. R is equal to 2x cubed over x, which is 2x squared. R is equal to 4x to the power of 5 over 2x cubed. That also gives you 2x squared once you simplify, as this cancels with this, and this cancels with this. So 2x squared is what you get. So you always get the same common ratio. And I hope that makes sense. If not, you can go through it once again. We're going to be moving on to a question if you think that will help you make it make more sense. So this is an application of the geometric sequence. So in this case over here, you have to apply the formula of the geometric sequence. So this formula that we learned over here, this one over here, this is what you're going to have to be applying now. So application of the geometric. 0.5, 0.45, 1.35, all the way to 12.15. This is a finite sequence, limited. It doesn't go to infinity, it stops at 12.15. So over here the question is, find the number of terms in this singular geometric sequence. I want you to go ahead and attempt this, and remember, I'm giving you a hint over here that you have to use this formula. So pause the video and try it out. It shouldn't take you more than a minute. Okay, so first things first, obviously write down the formula. So u of n is equal to u1 times r to the power of n minus 1. So your u1 over here is 0.15. You don't know what your r is, so over here you do 0.45 over 0.15. That is equal to 3. If my math is correct, which I don't trust my math, so I'm just going to check it real quick. Yes. I am too good at this game. So 0.45 over 0.15 is 3. So that is your common ratio now. R is equal to 3. So now you have basically everything to solve for this geometric sequence over here. Yeah, so now you have everything that you need to solve for this geometric sequence right here. So u of n being your last term in this case now. Now you put n as your last term. You don't need to specify what value it is. You don't need to specify anything yet. You just need to know that un, the number that is represented by n, and the nth term is 12.15. That is what it is. And that is equal to u1 times r to the power of n minus 1. So now you replace u1 and r with what you know. So we know that u1 is equal to 0.15. So we plug in 0.15 times you know r now, which is 3, 3 to the power of n minus 1. Now, if you use your calculators, you can try to figure out what n is over here. So once you use your calculators, as I am right now, you should get n is equal to 5. The final thing you'll get is 81 is equal to 3 to the power of n minus 1, and then you can just solve from there using the calculator. And I hope that makes sense now. That's the application of the geometric sequence formula. Now let's do another one. This is for you to attempt. So go ahead, pause the video, and try it out. Now this one I'm not going to explain simply for purpose of the video so that we can move on quickly. So in this case over here, it's the same thing as last question. 4 times minus 2, because they're giving you the common ratio is negative 2. First term is 4. So negative 2 to the power of n minus 1 is equal to minus 2048. Using calculator, that's the only thing you need to do. N is equal to 10. 10. Yes, now let's move on. So the sum of infinite geometric sequence. Now this is going to be a little bit complicated and a little hard to understand, but we're going to go through it slowly and very, very simply. So the sum of a finite geometric series is given by S of n is equal to u1 times 1 minus r to the power of n in brackets over 1 minus r. So this formula right here. And r cannot equal to 1 as anything, let's say x over 0. This is an undefined value. Undefined. So this cannot exist. N is the number of turns, u1 is the first term, r is the common ratio, everything stays the same. This is not the part that I want to focus on, as this is really easy to remember, it's a finite sequence, it's fine. But we have to worry about an infinite sequence, infinite geometric sequence. This is what they're going to ask you more. They might ask you in a finite, it might be like a 1 or 2 marker, but they're going to ask you about infinite geometric sequences too. And this is where theory comes into play. So this is really important to know. There's something called that convergent and divergent series. So an infinite geometric series is convergent. This is when the sum tends to a finite value as the number of terms get bigger. If a geometric series does not converge, it is said to be divergent. So usually when a geometric series is finite, when it's finite, it diverges. It is said to be divergent. An infinite geometric series is said to be convergent. I just want you to remember that right there. An infinite series is convergent. A finite geometric sequence is divergent. So the sum of n terms of a geometric series is this. This is for finite. Yes? But this applies to infinite sequences, infinite geometric sequences too, but only when r is between -1 and 1. As when it is in between -1 and 1, it will not approach, let's say, a very large value for your infinite for your summation of the infinite geometric series, right? And this formula is for finite, yes? So the infinite series, the one with this limited domain, is this formula right here. So S is equal to U1 over 1 minus R. This is for an infinite series. This is to help it create a finite sum. This is how an infinite series gets a finite sum. So U1 over 1 minus R. And I know that might not make sense, but in this case over here, for this formula right here, R has to be between -1 and 1. It's limited by that domain. Over here, for this one, for finite, since finite sequences will give you a divergent value, since it diverges, it will give you a large value. It might give you a large value, but it will give you a finite value. It will always give you a finite value since it's limited. Finite value. And that basically just means an actual value, like a number that you can read and represent and write down for your answer. But in an infinite geometric sequence, you do not know where the terms end, how big n gets. Yes? So, we are said to limit the domain of R, your common ratio, to -1 to 1, and change the formula in such a way that s is equal to u1 over 1 minus r. So just remember this. If it's infinite, you use this. If it's finite, you use this. Yes? And I hope that makes sense. If not, we're going to go through a question and hopefully it does. So, once again, it's a challenge for you. So go ahead and try this out and let me know what you think. Okay, now we're going to go through the question. So, a geometric series has first term 3 common ratio to find the sum of the first 5 terms. So they have limited it to 5 terms. They haven't asked for the infinite, like, summation of the geometric sequence, have they over here? So they've only asked for the summation of 5 terms, 5 singular terms. So they've asked for S5. That's what they asked for here. So we go back to our formula. Where's the formula? There it is. So we go back to the formula and we plug in everything we know. So we know U1 is 3. So 3 times 1 minus 2 to the power of 5. Yes, because it's 1 minus r to the power of n. R is 2. U1 is 3 over 1 minus r, which is 2. And you plug this into your calculator, you should get a value of 93. It's as simple as that. That's all you have to do for now. Just plug this in. It gets a little bit more complicated though when you come to infinite series. So I just want you to remember this note before you attempt this question. So this is a clear indication and a hint that this next question is going to be about an infinite series. And I beg you, please do not be confused by this sigma notation. Remember what we have gone through in at the start of this video about sigma notation. If not, I want you to rewind the video and go back and watch that note on sigma notation. This sigma notation is summation. Do not get confused by this. Summation. Do not get confused by this, dude. So I just zoomed in a little bit so you can see that this summation, it starts from the least value, which is 1, your least value of I being 1, and the infinite, and it goes up to the largest value, which is, it goes until infinity. So that means that this series, yes, you got it right. Yes, you did. This is an infinite geometric series. Now, I do not want you to get scared by this complicated value or anything like that. So we're gonna tackle this one at a time. So they've asked us 2 questions over here. So for what values of x does the series, whatever that series is, because I'm not reading it out, converge? So this is where stuff gets a little bit more complicated, more difficult. Yes? So lambda I is equal to 1. I like writing it out, and probably because you can't see the question very well anyway. As x cannot be equal to 2. Again, x cannot be equal to 2 as x over 0 will be an undefined value. So they've asked us for which values of x does the series converge. So over here, first thing we gotta do here is we gotta figure out what our r is over here. We know our first term, u1, is going to be 1 plus x over 2. Yes, that's our u1. So what is our r? What is our common ratio? So let's just try to up the numbers of I. So u2 will be that means when I is equal to 2, 1 plus x over 2 to the power of 2. And immediately there should be like a blinker going off in your head, you know, it's like, wait a minute. And if I do u3, hopefully if you haven't gotten it yet, you should get it now. So 1 plus x over 2 is over 3 to the power of 3. So what is r? Well, r is the same as u1. 1 plus x over 2. This is your r. So we know in this case that this is an infinite series. And they've asked us, where does it converge? So that means that since we know our r, we have to find out for which values of x does it converge. So we go back to our note that we made over here. R has to be, for an infinite series, r has to be between -1 and 1. So what we do in this case is we put r between those two. We jail up r. So r has to be less than, greater than 1 or less than 1. -1, greater than -1 or less than 1. Yes. I am tweaking today. Anyway, 1 plus x over 2 -1, and 1, since we know that this is r. This is our r. So over here, now what we do is we solve this. We solve it. So we bring 1 to this side, we bring 1 to this side. So -1 here, -1 here. It goes -2, bam, 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 0. Because it goes -1 this side, -1 this side, so it becomes -2, and this one becomes 0, as 1 minus 1, 0. And then we do multiplied by 2. So this becomes -4 is, x is greater than -4 and less than 0, as 2 multiplied by 0 is just 0, 2 multiplied by -2 is -4. So for these values of x, it converges. But mentioned in the question is that x cannot be equal to -2, so we have to mention that once again, as our domain is still limited, or x is still limited, as -2 is mentioned inside this range over here. It goes -4, -3, -2, but in the question over here, it says that x cannot be equal to -2. So this is our answer to the first part of this question. Now let's go into the second part. So they asked us, find the sum for when x is equal to -1.5. Yes? So again, this is an infinite series, so you do not use this formula here. You use this formula here. This formula, this one. And I love this formula a lot because it's really easy to remember and really simple to do. So u1 over 1 minus r, right? So in this case over here, x is given by x equal to -1.5, which, let's check, is between the range that the series converges, so it is applicable. So when this occurs, you plug in x is equal to 1.5 into your equation, and you solve for it. So once you plug in x is equal to 1.5, so back into this equation over here, since I don't have space, I won't be writing it down, but once you plug it in, you should get the value for u1, which is 1 plus -1.5 over 2, which is, if I just do it in my mind, over 2, -0.5. Yeah, negative 0.5. Yes, -0.5. So it should be -0.5 and 1 minus 1.5. 1 minus the r, which is 0.5, right? So if you plug in r is equal to this, so if you plug in -1.5 here too, you should get 0.5, right? So 1 minus of minus 0.5, you get 1.5 at the bottom too, which is equal to -1 over 3. Yeah, sorry, I took a while on that. Yeah, I didn't have enough space to explain that too well, but I hope you understand. I just did some quick mental maths over there. Whew. So now let's move on. Financial maths, and I love this topic too, as it is just a formula. So this financial maths that the max, sorry, that they'll ask you in this sort of question, in these sort of questions, will be based on compound interest, and just repeatedly adding interest. That's what they're going to be asking you, interest related questions, especially compound interest. So you can go through this if you want, but they don't usually ask you on this, and they rarely ever ask you this. Like, no, sorry, let me rephrase myself. They never ask us on this. Like, never. I have not seen any questions based on this ever, and I've been doing questions for a very long time. So I'm just going to briefly explain this because it's in the syllabus. So the value of compound interest investments after n periods of time is this formula over here. And I'll be representing it in an easier way in the next slide. But this U0 is your initial investment. So that means, let's say you're putting in 5,000 to save in the bank, and your interest rate per year is 7%. Yes? So that means that your I, will be 0.07. That's what your I will be. And N is the time periods. So that means like how many years and how many times it's compounded annually. And this is represented better in the next page. So this is the formula for compound interest that you should be using. It is really simple to use and really easy to replicate in the exam. And you will have the formula for this in the exam too. So FV is your future value. P is your principal value. So again, what value did we take here? 5,000, yes? 5,000. The rate of interest is 7%. And in this case over here, you do not have to represent it as 0.07. As if you put in R as 0.07, you will still do it, you will still divide it by 100, which is not right. 7% is like 7 over 100, right? So that's basically what they're representing over here. They're doing it for you in the equation. So you represent it as 7%. You don't represent it as 0.07. T is the total time span. So that means how many years or months, whatever they ask you in the question, usually in years. So I'm going to write years over here, right? And then the number of times interest got compounded annually. So annually means in 1 year, in one singular year. How many times is interest applied? So let's say your thing is 7% and you have an amount of 5,000. So 5,000 and you stored it for one singular year. So 1 year. So in that 1 year, to get to your X amount in month, let's say it was, so let's just divide this up by 4. So 1, 2, 3, and 4. So in each of these 4 months, since I do not know my months, I'm not going to be stating any months, but throughout this year, in these 4 months, interest was applied. So that means that your 5,000 was initially multiplied by 1.07. And then this amount over here was again multiplied by 1.07. And this cycle was repeated 4 times in 1 year. So that means in 1 year, your interest was applied 4 times. That's what it means to be compounded annually. So that multiplied by the total time span is what your power will be, as represented in the question. So I want you to go through this really, really thoroughly because it's really easy concept to understand, and you should not be losing marks on this whatsoever. So pause the video and go through it one more time. Now let's move on to a question. I want you guys to attempt this first. I want you guys to attempt this question real quick, and I'm gonna go through it later. So pause the video and attempt this question. Hopefully you've attempted it by now. So now let's go through this question. So they're asking 5,000 is invested for 4 years at 7%. Oh, damn. Okay. Damn. Interest is compounded annually. Yes, so interest is compounded annually means that in 1 year it's only applied once. So 1 year, one time interest charge. That's what compounded annually means. Yes? So that means that your T, your N over here is going to be 1. So let's write down everything from our formula. So present value is 5,000. So is it written as P over there? Yeah, so P is, come on, why isn't it working? Yeah, there we go. P is 5,000. FV is your question mark. That's what we're trying to find, right? And then N is your number of years. So 4 years. Yes? Your T is 4 years. N is 1. Yes? Yes. So now we do our equation. So FV is equal to P, so 5,000 times by 1 plus 7%, 7 over 100, times N is just 1, so we can leave it at that, to the power of 4, as it's T times N, and N is 1, T is 4. So to the power of 4, which should get us our value of, enter into the calculator, and what do we get? Sorry, it's technical difficulties going on over here. Okay, yes, finding out the value. So we should get a value of 6553.98. Yes, that is our answer to A, right here. Now B is how much interest has been earned. So to find out how much interest is earned, you just do your FV, future value, minus your P. So if you take your future value, which is this, and your present, which is this, and you subtract them, you should get a value of 1553.98. Do include the sign, so in this case dollars. I just don't want to confuse you by writing it, thinking it's a number, because my handwriting is, amazing. So yeah, now let's move on. I hope you understood financial math. So there's some technology listed over here for your own use. Pause the video and see if you have a Casio FX CG50. I would highly recommend going through this slide over here and learning all the techniques, as it would save you a lot of time instead of having to write down the compound interest formula, instead just doing it on your calculator really easily. So I would recommend you go through this if you have a Casio FX CG50. So now, wait, someone's at the door. Knock, knock. Yo, who's there? It's Pascal's Triangle with his dog, the binomial theorem. So I'm gonna get into why Pascal is that awesome and why binomial sucks. So before we get into any of this, this is different from geometric sequences, different from financial maths, different from anything that you've learned till now. And I want you to pause the video right now if you haven't understood anything. Go back and revise whatever you haven't understood right now. Okay, now hopefully you've gone through the slides before if you haven't understood anything. If you're still with me, then great, let's move on. So, Pascal's Triangle. This guy's great. Pascal is great. I know him personally. But that's not what I'm here to talk about. Pascal's Triangle. So the values on the end of each row are always 1. So these values right here are always going to be 1 in Pascal's Triangle. So obviously you see over here that this is a triangle, hence the name Pascal. No, triangle. Pascal's Triangle. Yes. So Pascal was the guy who invented this basically and found this out, discovered this thing, this triangular formation over here. So I'm going to write it down for you and hopefully you understand it. So let's start off with a 1 and 1. And then we add another 1 and another 1. But we want to fill out this middle part. We don't want this to be empty. We want everything to be filled out. Sorry. We want this to be filled out over here. So we add these two values that we have over here. So this becomes 1 plus 1 becomes 2. Now I want to add another row, another row. I want to add another one. So again, this part is filled out. This part isn't filled out over here. So to fill this out, we add these two values again. So 1 plus 2 is 3. These add up to get this. And 1 plus 2 over here is again 3. Now I want to add another, 4. 4 is a pretty good number. 4 is an even number. So, oh man, but again, it's not filled out in the middle. So what do? We take 1 plus 3, which gives us 4 over here, 3 plus 3, which gives us 6 over here, and 3 plus 1, which is 4. Now I hope you get the gist over here. It just keeps on repeating and repeating and repeating for each of the powers. So this is row 1 to row 4 now. So that means to the power of 1 to the power of 4. I want you to remember what I'm saying over here. The power of 1 to the power of 4. Now let's go into that a little bit. So we know, let's say we have a plus b, right? And let's say it's to the power of n. Now we're going to take different values of n over here. So a plus b to the power of 1, that means that the coefficients of a plus b, that's what happens when you do it to the power of 1, are 1 and 1. Okay, fine. A plus b to the power of 2, their coefficients are a squared, so 1, plus 2ab plus b squared, 1b squared. I don't know if you see a pattern yet over here. I don't know if you see the pattern yet here. But there is a pattern, trust me. And then, if you take a plus b to the power of 3, it is 1a cubed plus 3a squared b plus 3a b squared plus b cubed, 1b cubed. So now in each expansion you see that there are different coefficients, right? These are coefficients. So you have your A and you have your B, but the coefficient over here, the number, the actual number that represents this, let's say you have an A and B, the number that represents this is always different for each power, the higher power that you have. And that is almost impossible. Let's say you have in a question A plus B to the power of, I don't know, like 7. Like, what are you going to do then? Just expand again and again? No, you can't do that. So you have to use something different. And that's where Pascal's come in. Pascal's triangle comes in. So let's take our first equation of here. A plus b to the power of 1. So that gave us coefficients of 1 and 1. Fine. Huh. Okay, row 1 and 1. That could be a coincidence, you know. Row 1 and 1 is 1 and 1. But now let's go on to a plus b to the power of 2, which is 1a squared plus 2ab plus 1b squared. So I want you to just focus on these coefficients. So 1, 2, and 1 in that order. Huh. Let's look at row 2 over here. 1, 2, 1. Okay, why has it done that? 1, 2, and 1. Okay, that could be a coincidence again, you know, but let's look at a plus b to the power of 3, which is 1, 3, 3, and 1. Damn! That's what row 3 is. 1, 3, 3, 1. And as you can see here, it just keeps on repeating and repeating and repeating. I don't know why this 4 is here, by the way. It just keeps on repeating, repeating, and repeating for each of the values that you have. If you're expanding something to the power of a large number, you have to use Pascal's triangle. You cannot expand it by multiplying again and again and again and again. You cannot do that. That's a lengthy process. You won't have time in the exam. So they invented something called Pascal's triangle to help you out over here. And I hope you understand the gist of what Pascal's triangle is over here. Now we're going to talk about Pascal's dog, a close friend at the same time, binomial expansion. So in questions, they are going to be asking you stuff like, what is the coefficient in this expansion? So this is a trial question for you. What is a plus b to the power of 7? What is the coefficient of, let's say, a plus b to the power of 5? And now you're telling me that you're not going to use Pascal's triangle or binomial expansion. You're just going to expand until you get the coefficient? And that you can't do that. Surely you can't do that. So what you got to do over here is you got to use the binomial theorem, the binomial expansion. So this simplifies things a lot, right? So there's something called n choose r, which is also represented by nr, which can also be represented by n factorial over r factorial n minus r factorial. So factorial, I'm going to explain that now. So let's say you have 6 factorial. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. That's what 6 factorial means. So n factorial means n times n minus 1 times n minus 2 times until like n minus infinity at that point. So that's what factorial means. And I don't want you to focus too much on this for now, as we're just going through mainly the basics of it. I just want you to keep this in mind since it's written over here. So the binomial theorem, we'll get back to this slide in a bit. I don't think you'll understand this just about yet. This is nicer. This is a little bit nicer. So to find out the expansion of a plus b to the power of n, you need your coefficient, you need the power of a, you need the power of b, right? And then for the next term, you need the coefficient, you need the power of a, you need the power of b. So in this sequence over here, you see, let's take a plus b to the power of 3. You go a to the power of 3, right? And it goes a to the power of 2, and then it goes to a, and then a to the power of 0. You see, it's a sequence. Everything over here is a sequence. So to figure this out, you need to use the binomial theorem. The binomial theorem states that n choose r, right? nr or n choose r. I like using ncr, right? These both are the same thing. Once again, I'm saying that. N choose r times by a to the power of n minus r times b to the r, right? This is how you represent your binomial expansion. So let's say your n can be, let's say 8 plus b to the power of n. That's what your n is, right? So your n in this case would have been 7. Your n is 7, right? So to find out the coefficient, you have to put different terms of r. I don't know why I took that as a bracket. This should be n choose r. N choose r. Yes. So to find out the coefficient, you can all do Pascal's triangle up to 7. That would be lengthy, but not as lengthy as obviously like multiplying again and again. But instead you use the binomial theorem. So this n choose r times by a to the power of n minus r times b to the power of r. So for r, what is r, you might wonder? N never changes. N will always be equal to 7. But r goes from 0 to 1 to 2 to all the way to 7. So there will be a point where it will be 7 choose 7. There will be a point where there will be 7 choose 0. That's how it will be. And each of these values will give you a different value as you use this formula, or you use the most like non-mental way to do this binomial expansion and just plug it into a calculator like a normal human being, you know? So you just plug in 7, which is your n, choose c, 7c r, whatever r value you're trying to find for your coefficient. So this is what you use to find out. So let's say what was I trying to find just now? I was trying to find something. The coefficient of a plus b to the power of 7, same thing, same question, but I want the coefficient of a to the power of 3 and b to the power of 4. That's what I want. I want the coefficient of that. Help me, please. I need the coefficient of this. Now I want you to remember this, and I want you to try and solve it. Pause the video and try. Don't get it? It's fine. We're going to go through it now. So let's just write down our formula for the binomial expansion. So n choose r times by a to the power of n minus r times by b to the power of r. That is our binomial expansion. So I don't want you to worry about this just yet. I did this, explained this in detail, just so that you can understand what this represents. It's the coefficient. So we know that a has to be to the power of 3 and b has to be to the power of r. Now we need to represent that here. And how do we do that? We know n has to be equal to 7. So a to the power of 7 minus r and b to the power of r. So 7 minus r has to be equal to 3, as that is the value that we want to the power of a, and r has to be equal to 4 for b to be satisfied. So r has to be 4 over here, and they both match and they both work. So now we know what our n is. The n never changed. N is equal to 7. But we know what our r is this time too. We know our r is equal to 4. So we do n 7. I'll just write in my words. 7 choose 4 into our calculators, and we get the value, and that is our coefficient for that value. And I hope that made sense. If not, rewatch the video, and hopefully you should be able to get it by now. That is how you use your binomial expansion, and it's just more complicated way to express it over here to confuse you a little bit and to make me look a little smart, you know? So now let's do this one last question. I promise this is the last question for today. This has been a really long video. You're probably really tired. So let's just do this one last question. I want you guys to attempt this question right here. Pause the video, please, and do this question. Let's see if you get it. Let's see if you can get it. Okay, now hopefully you paused the video and had an attempt at it. Now let's start. So write down the first 3 and last 2 terms of this expansion and do not simplify your answer. Oof, this seems like a really rough one, you know? But it's not as rough as it seems. So let's go for the first 3 terms first. Let's go for the first and last term. Okay, let's go for the first and last term. So first term, how would we do this? So we know our binomial expansion formula, which is n choose r, right? A to the power of n minus r and b to the power of r. So we know that r first starts off at 0, and then it goes to 1, and then it goes to 2, and then it goes to 3, and then all the way up to 12 in this case, because n is represented by 12. So n is equal to 12, and r goes first from 0 all the way to 12. So if you plug in r is equal to 0 and n is equal to 12, that should be your first term. Does that make sense? So 12, 12, choose 0, right? A to the power of 12 minus 0, which is 12, and b to the power of 0. So your answer should be 12 choose 0, which is 1, so a to the power of 12. That is your first term. Yeah, that makes sense? Now when you're plugging into the calculator, you have to put 12c, this c value. This is what you have to put in. You cannot put it like this, so you have to put it like this in every single calculator that you use. So remember this, if you do not know how to put C into your calculator, search it up, you'll find it online. It's different for every single calculator, so I cannot tell you how my calculator works. And you can do this for every single one of the terms that is given. So let's go through the last term now, really, really quickly. So last term, so 12, right? And you know that the last term that r is going to take is 12. So 12, choose 12, right? So a to the power of 12 minus 12 times by b to the power of 12. So 12 choose 12 should be 0. So this is equal to, 1, should be 1. So that means b to the power of 12. That's your first, that's your first and last term. Now, I'm just doing the first and last term as it's the easiest to do, but I have posted the answers on the Canva slide, so go through it, and hopefully you've gotten it right. If not, rewatch the video, and hopefully you should understand again, and I want you to try again. And then, after you've gotten all the questions right in this slide, in this PowerPoint, I want you to try this challenge question out, which I have attached the mark scheme to over here. And this Canva slides will be in the description below, so please do go check them out and use them for preparation for your exams. Along with this, I've also attached the link that you can book one-on-one sessions with me whenever you want, whenever I'm free, and they are completely free for you to check out. So do that if you want any extra help. I am there if you need me, because I've been in your situation, and man, did IB Maths AHL not make it easy on me. Anyway, thank you for watching this video if you got to the end. Take care, have a good day. See you later, dosers.